Just when you think AI development might be hitting, like, a plateau, something comes along that completely resets your expectations.
Oh, absolutely. It feels like we're accelerating, not
Yeah.
slowing down.
Yeah, we're moving way past just automating simple tasks. Now, AI is starting to grapple with these really fundamental challenges, things we thought were purely human territory.
It's a genuinely astonishing time. The shift isn't just about, better image recognition or text generation anymore. It's stepping into actual discovery.
And that is exactly why we're doing this deep dive today. We're looking at AlphaEvolve, the new AI agent from Google DeepMind.
Right.
On the surface, it's a coding agent, but its real goal,
Yeah.
well, that's discovering and optimizing brand new algorithms. That feels pretty groundbreaking.
It really is. At its heart, AlphaEvolve takes the creative power of large language models, specifically the Gemini family,
Right.
and uses that to generate novel code, potential solutions to complex problems. But, and this is crucial, it doesn't just generate, it pairs that with a really rigorous automated evaluation system. Ah, okay. So it's not just like throwing spaghetti at the wall code-wise, there's actual testing and refinement baked in.
Precisely. Think of it maybe like an evolutionary process, like in biology.
Mm.
The Gemini model suggests different ways to code a solution. Then automated tools check very carefully. Does it work? And, really importantly, how well does it work based on clear, measurable criteria?
Got it.
And then the best code, the top performers, they feed back into the system to spark even better ideas.
So it's this continuous loop, like propose, test, learn, improve. And you mentioned its impact is surprisingly broad.
Exactly. This isn't just some lab experiment gathering dust. AlphaEvolve's discoveries, they're actually being deployed inside Google's own infrastructure,
Wow.
making real-world efficiency gains. But perhaps even more revolutionary is its potential to push boundaries in fundamental science, especially mathematics, which is why we're here today, right? Our mission is to really understand what AlphaEvolve signifies. What does it tell us about where AI is heading, and what are the implications, for technology, for science, for everything?
That's the core question. We're looking at more than just new software. This could be a fundamental change in how we approach and solve really, really difficult problems.
Okay, let's get into the nitty-gritty then. How does it actually work? You said an ensemble of Gemini models.
Yeah, so to get both, like a wide range of ideas, but also deep insights, it uses a mix. Gemini Flash is used, well, think of it as casting a wide net. It's fast, efficient, generates lots of initial possibilities.
Okay, breadth first.
Right. Then Gemini Pro, which is, the more powerful model, takes the most promising ideas from Flash and really digs into them, much more detailed exploration.
So Flash for speed and volume, Pro for depth and refinement.
That's a great way to put it. And once they generate code, potential algorithmic solutions, then comes the critical part. The evaluation. AlphaEvolve automatically runs, tests, scores these programs.
And it uses objective, quantifiable metrics, you said.
Absolutely critical. That's the key.
Takes the guesswork out. No subjective, this feels better.
Exactly right. It's all about measurable outcomes. That makes it perfect for fields where progress is really clearly defined, like math and computer science. There's no ambiguity. The code either... What was that?
Right. Okay, so generate, test rigorously, feed back the best results to generate even better stuff. That loop makes sense. Now, you mentioned real-world use inside Google. Where exactly?
So one of the biggest impacts so far has been in optimizing how Google manages its enormous data centers.
Okay.
AlphaEvolve found a new heuristic, which is basically a smart shortcut, a rule of thumb for
Awesome.
Borg. That's Google's system for managing all the computing tasks.
Yeah.
And this heuristic, it's been running live in production for over a year now.
A year? Wow. And the result?
It's managed to recover, on average, about 0.7% of Google's compute resources worldwide.
Now, hang on. 0.7% sounds small, maybe. But at Google's scale, that must be absolutely massive.
It is. It's a huge efficiency gain. It means they can do significantly more with the exact same hardware. And what's really interesting here is that the code it produced wasn't some kind of, unreadable black box.
Well.
No. It generated code that human engineers can actually read and understand.
And why is that so important? Isn't performance the main thing?
Performance is key, but for practical deployment, readability is vital. It means engineers can interpret it, they can debug it if something goes wrong, they can predict its behavior, and, crucially, they can confidently deploy and maintain it. That practicality is just as important as the raw numbers.
That makes total sense. It has to be manageable in the real world, not just theoretically optimal. Okay, where else? Any other Google applications?
Another really cool area is hardware design, helping design their tensor processing units, their
The
PPUs.
chips for AI.
Exactly. AlphaEvolve actually proposed a rewrite for a key arithmetic circuit. It did this in Verilog, which is the language hardware engineers use to describe chip designs.
A rewrite. To do what? Make it faster, smaller.
The goal was to eliminate unnecessary bits within the circuit, a circuit that was already, heavily optimized.
Right, sounds risky. Changing fundamental hardware.
Extremely, which is why any changes proposed by AlphaEvolve had to go through incredibly rigorous verification checks. They had to prove, absolutely, that it maintained perfect functional correctness. You can't make mistakes there.
So wait, AI isn't just designing new chips from scratch. It's collaborating with human engineers to refine existing super complex designs.
That's precisely it. It's a synergy. The AI suggests potential improvements, things humans might not spot, and then the human experts validate and integrate them. It could really speed up how we develop next-gen hardware.
That's incredible. So data centers, chip design, what about the AI models themselves? Training them, running them?
Yes. Big impact there, too. AlphaEvolve has helped make both training and inference more efficient. For example, matrix multiplication. It's fundamental to training models like Gemini.
Right.
AlphaEvolve found a better way to break down those huge matrix multiplications into smaller chunks. This sped up that specific critical kernel in Gemini's architecture by 23%.
23%. And what did that translate to overall?
It led to about a 1% reduction in the total time needed to train these massive models.
Again, 1% sounds modest, but training these things takes enormous resources, right?
Yeah.
Time, energy, cost.
Exactly. So a 1% saving is actually very substantial. Plus, there's another benefit.
Oh, yeah.
The time it takes human experts to find these kinds of low-level optimizations, it used to take weeks of specialized work. AlphaEvolve can explore these possibilities in just days.
Wow, so it frees up the human experts for higher level problems.
Yeah.
That's a huge research accelerator.
Absolutely. And it goes even deeper. I think you read about optimizing like the really low-level GPU instructions.
Yeah, the stuff that's normally handled by compilers that humans barely touch.
That's the stuff. It's already hyper-optimized, typically. But AlphaEvolve managed speedups of up to 32.5% for the flash attention kernel.
32.5. For flash attention, that's wild. That kernel is critical for transformers.
It really is astonishing. It shows it can find these really non-obvious improvements even in code that everyone assumed was already squeezed dry. It makes even the best engineers more productive, potentially saves more power, more energy.
Amplifying human expertise, not just replacing it. Okay, let's switch gears. Mathematics. This feels like a different level entirely. How does it help with fundamental math?
Yeah, this is where things get seriously fascinating. Because it's not just optimizing code that already exists, it's actually discovering new algorithms, tackling problems in math that have been unsolved for ages.
Was this just to guess formulas?
Not quite. You give it a sort of basic code framework, and it can then design specific components, build novel procedures to attack these really complex mathematical challenges.
And the big example here is matrix multiplication again, right? DeepMind's done work there before with AlphaTensor.
That's right. AlphaTensor was huge. But now AlphaEvolve has pushed it further. It found a new way to multiply 4x4 matrices that have complex numbers in them, using only 48 scalar multiplications.
And why is 48 significant?
Because the best method known before this, Strawson's algorithm, which is ancient, from 1969, needed more operations than that. So this is a concrete improvement on a fundamental algorithm people have studied for over 50 years.
Oh.
And interestingly, AlphaTensor, which was built specifically for matrix multiplication, only found improvements for 4x4 matrices using binary arithmetic, not these complex numbers.
So AlphaEvolve, the more general system, actually beat this specialist tool in this specific case.
It seems so,
Right.
which really highlights its versatility, its potential to find breakthroughs across a wider range of problems. But it's not just matrix multiplication.
Right, you mentioned it tackled lots of open problems.
Yeah, the team threw it at over 50 open problems from all sorts of mathematical fields: analysis, geometry, combinatorics, number theory, you name it.
Setting that up was quick.
Apparently, yes. Often just a few hours per problem, which shows how adaptable the system is.
So the results, did it just find what we already knew, or?
Well, in about 3/4 of the cases, 75%, it rediscovered the current state-of-the-art solutions, which is great. It validates the approach.
Sure, confirms it works.
But even more excitingly, in roughly 20% of those problems, AlphaEvolve actually improved on the best previously known solutions. That's real, tangible progress on genuinely hard, long-standing mathematical puzzles.
That's amazing. Can you give an example, one specific breakthrough?
Sure. A really cool one is the kissing number problem.
The what now?
The kissing number problem, it's a classic. It asks,
Wow.
what's the maximum number of identical spheres you can arrange so they all just touch or kiss a central sphere of the same size?
Okay. Sounds simple, but I bet it gets hard fast.
Oh, incredibly hard in higher dimensions. So for 11 dimensions, AlphaEvolve discovered a configuration with 593 outer spheres touching the central one.
593. That was new.
Yes. It established a new lower bound for the kissing number in 11 dimensions, better than anyone had managed before.
An AI agent making progress on a centuries-old geometry problem. That really drives home the potential, doesn't it?
It really does. And the researchers behind it, they stress this point. AlphaEvolve shows a clear progression, moving from very specific problems towards these much broader, more complex, real-world type challenges.
And presumably it'll just keep getting better as the underlying LLMs, like Gemini, improve.
That's the expectation. As the core models get smarter, better at coding, better at reasoning, AlphaEvolve's capabilities should scale right along with them. The trajectory looks, well, very promising.
And are they planning to let others use it? Academics, maybe?
Yes, definitely. They've been building a user interface to make it easier to work with, and they're planning an early access program for some academic researchers. The goal is broader availability down the line.
That could be huge. Really democratize this kind of algorithmic discovery. So just to pull back a bit, it's not just for Google systems or abstract math problems.
Not at all. The core idea is incredibly general. Basically, if you have a problem where the solution can be written as an algorithm, and you have a way to automatically check if that algorithm is correct and how good it is.
Then AlphaEvolve could potentially tackle it.
Exactly. That opens the door to a vast range of possibilities. Think about fields like material science, designing new materials from scratch with specific properties.
Or drug discovery, finding new candidate molecules.
Precisely. Or sustainability, designing more efficient chemical processes maybe, even improving business operations. Anywhere you need a better algorithm, a better procedure.
Wow, okay, the potential applications are just mind-boggling. So let's try and bring this all together. Key takeaways from this deep dive.
I think the biggest thing is AlphaEvolve's twinability. It can creatively generate novel algorithms, and it can rigorously optimize them. We're seeing concrete proof of this already with the efficiency gains inside Google and these genuine breakthroughs in mathematics.
And for you listening to this, it really offers a window into what AI is becoming capable of. It's shifting from just automation to actually augmenting human creativity and discovery. It's a tool for tackling problems that seemed almost out of reach before.
Right. It really highlights the power you get when you combine that sort of intuition or creativity of large language models with the cold, hard logic of automated evaluation. It's a powerful engine for finding new solutions.
So here's something to leave you with. We've seen AI get really good at doing things humans already know how to do, just faster or cheaper. But AlphaEvolve suggests AI might start discovering truly fundamental new knowledge, new efficiencies, things we don't know. What other massive challenges in science, engineering, medicine, climate might suddenly become solvable with tools like this? It really makes you ponder the whole future of innovation, doesn't it?